Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about graph models. So my name is Asma Maisarah binti Ahmad Sebudin. My number matric is 223022 and this is my group member.
My name is Sabrina Balqis binti Azahadi and my matrix number is 224007. I will begin with an introduction about graph models. So graph VE consists of non-empty set V of vertices and set E of edges. Edges means connect either one or two vertices called endpoints. So for an example, graph GVE where V A B C D and E A B A C B C and C D. So it means if this A B C and D, so AB means A go to B and then AC like this, BC and then CD. So this is the basic of graph.
Okay, so let's move on to the next, which is type of graph. The first graph that I'm going to explain to you is a simple graph. So simple graph is the graph is undirected and does not contain any loops or multiple edges. Each edge connect two different vertices. No two edges connect same two vertices. So for example, I'm gonna draw the graph for you guys. This is A and then B, C and D. So it said that each edge connect two different vertices. So I'm going to connect A to B and then A to C. So A is already connect to two different vertices. Same goes as B. Yeah, and no two edges connect same two vertices. So I cannot do like C to B. So this is not a simple graph. Okay, and then we have multi-graph, multiple edges between the same set of vertices. In other words, it is a graph having at least one loop or multiple edges. So for example this is point A and then this is point B. So it said that having at least one loop. So I'm gonna do A to B and then B to A. So this is the example of multi-graph.
The third one is loop. So edge that connect a vertex to itself. So it means like this A and then because it is a loop, so it is like this. So a directed graph means the directed edge associated with AB begins at A and ends at B. Okay, for an example, so this is A, B and C. So A will go to B because it is a directed graph, so we need to put an arrow to it, and then B goes to A, and then since it ends at B, so you can go here and then up here because it still ends at B. So the last one is pseudograph, which include loop as well as multiple edges. So if this A and then this is B and then C, so include loops. Loops mean like the first one, the third one, I mean like this is a loop, and then since it needs multiple edges like this, multiple edges, so this is a pseudograph.
For the summary of what we have learned so far, you can refer to this table, which is the summary table. We have type of graph, is it directed edges or multiple edges allowed or loops allowed. So such as simple graph, there's no directed edges, also there's no multiple edges, and there's no loop. So that's for the simple graph. And then for the multi-graph, there's no directed edges, there is a multiple edges, and there's no loop. And for the other graph, you can read it on the slide.
Next is special types of graph. The first one is complete graph, where every two vertices pair are joined by exactly one edge. So in another words, complete graph is also a simple graph which doesn't contain any loop or any other, it's just a simple graph. So the first one is like this. This is a complete graph, but you cannot draw a loop in it because it is like a simple graph. Next is like this, where two vertices pair are joined by exactly one edge. Or another example is like this, because each vertices is connected with others vertices. So this is considered as complete graph. So the second one is cycle graph. A graph consists of a single cycle. So for example like this is a cycle graph because it is a single cycle where you start here and then you will finish at here too. So another example is like this. You go here, here, here. This is also considered as cycle graph. And next is wheel, which obtained when an additional vertex added to cycle. So it is related to the cycle graph, but it has a vertex like this. So this is a cycle graph, but then if you do this is considered as wheel graph.
For the fourth one, which is n-cubes or hypercubes, graph with vertices representing to the power of n bit strings of length n. Adjacent vertices differ by exactly one bit position. So for example, I have 0 and 1, and I connected. So this is one bit position. So the second example we have so the original is 0 1 and then 0 1, everything is 0 1, but you need to add 1 here and 1 here, and then 0 and 0. That's all you need to do. So for the last one, which is bipartite graph, it's a simple graph. Its vertex v can be partitioned into two disjoint subsets such that edge connects vertex from one subset another. So I give an example here. We have, this is A, and then B, C, and D, and then we have here 1, 2, and 3. So we're gonna name this one. We're gonna name this one as S1 and this one as S2. So bipartite graph is that you cannot connect S1 to S1 or S2 to S2. So I'm gonna draw the line A to 1, and then B to 2, C to 3. So D you can make it D to 1 or D to 2 or D to 3, whatever you want. because D is S1 and 1, 2, 3 is S2, so you can connect it to which S2 element that you want.
That's all from us. Thank you for listening, and may Allah give us full mark.
Bye bye.